The factor pattern of the day is factoring by grouping. The idea behind this is really not hard to follow, but can be a little bit confusing. However, the procedure itself is quite simple. Let's start with the big idea, though. If I asked you to factor AB plus AC, of course you would all know at this point that the first step of every factoring problem is to look for a GCF. And in fact, these both have an A, making it the greatest common factor. Put it on the outside of the parentheses, and that leaves on the inside B plus C. The big idea of factoring by grouping is based on this exact concept, the concept of the greatest common factor. The problem is it looks different, and therefore it's just slightly more confusing, or visually confusing. But let's go back and talk about what is A. A is a variable, and a variable is something that represents a number. If, for example, I say x plus 1, it's a variable expression, but it still represents a number. So A and x plus 1 are two different ways to represent numbers that are unknown at this point. Keeping that in mind, if I say to you x plus 1 times b plus x plus 1 times c, you can see that just like A is a number, x plus 1 is also a number, and therefore, if I want to factor it, I check out this pattern here and I say, okay, A was the common factor, I factor it out, and that leaves B plus C. Well, it looks different, but it's still, x plus 1 is still a common factor. X plus 1 is a number times B, which is another number. If those two numbers are multiplied together, then x plus 1 is a factor of x plus 1 times b. And the same goes for x plus 1 times c. Therefore, we will follow this exact pattern above, and where I had A, I will put x plus 1, and where I had B and C up here is the same thing. I've factored it out, x plus 1 times B plus C. Now, unfortunately, in this milieu, I can't put it in color. If you remember on the board, A was first in pink, and then x plus 1 was in pink. But if you take a step back, you can see in this particular expression, x plus 1 is in the same place as A. I've just substituted it. That gives us the big idea of how we're going to go about factoring these more complicated looking expressions. Let's take a look and see. How would I factor 5 times A minus 3 minus 2A times A minus 3? Again, 5 times A minus 3 is a number. 2A times A minus 3 is a number. These are each factors. And we can see that A minus 3, 5 is also a factor, and negative 2A is also a factor. But we can see that A minus 3 is the GCF, so I can factor it out. And then what's left is 5 minus 2A. In this example, you can really see what I mean when I said understanding what's going on here, that we're factoring out the greatest common factor, is much more difficult than the actual procedure. In this procedure, all I have to do is put the A minus 3 in one set of parentheses and the 5 minus 2A in the other. It's really that simple. And in fact, just so you remember, A minus 3 times 5 minus 2A is the same as 5 minus 2A times A minus 3. I can put them in any order. So I could have said that I could have started with the 5 and said 5 minus 2A times A minus 3. Let's try another one and just get the idea of how simple it is. 6 times x plus y plus w times x plus y. Okay? X plus y is the common factor. I factor it out, and I have x plus y times, and the other two terms there are 6 plus w. I think in your homework sheet they might list the answers in the other order, so, or it's the same thing to say 6 plus w times x plus y. So that is pretty easy. They don't start out quite that simply. In fact, this doesn't look like the same factoring pattern, but as you will see, it actually is. 2ab minus 6ac plus 3b minus 9c. Well, right away in class you were able to say, what's different about this? And the thing that's different, there are no parentheses. And there's also no greatest common factor. I'm sorry, that's bothering me. That B is sloppy. There is no common factor among all of the 4 terms. So it looks like we don't have a place to start. However, I can put in parentheses. I can group these and think of them as 2 different groups of terms. So that would be my first step, would be to group. And now that they are grouped, I can see that each of the 2 groups has common factors. In this polynomial, the greatest common factor is 2a. So I can factor out a 2a, and I'm left with b minus 3c. And by the way, really at this point, the whole procedure of factoring out the GCF needs to be automatic. So factor out the GCF of each group. Now, hopefully, it hasn't been lost on you. Actually, let's finish this. 3 is the greatest common factor here. B minus 3c. Now remember that really easy thing that we noticed on the last slide, that I can, in one parentheses, put 2a plus 3, and in the other, b minus 3c. And I'm finished. So this time I put it in this order. It's fine. These 2 things go in one of the parentheses, and these things go in the other. There's only one of them because I'm factoring out the common factor. Whether or not you understand that, though, just for right now, as you're learning it, just practice it and then keep thinking about it. You know, as always in the work that we do, things can have more complicated steps. Actually, I'm going to put step 3, I'm just going to call that finish. Do the easy thing. Put them in the parentheses, these 2 parentheses. Okay? So, bring up a kind of problem that does have an issue. If I say AD plus 3A minus D squared minus 3D. I'm going to write this twice, and you'll see why. I want you to remember what the original problem is. This is the original problem. Okay? So now I'm going to write it again, because this is the one I'm going to work on. 3a minus d squared minus 3d. Okay, so I know if there are 4 terms here, I need to group them. By the way, there are other ways to group, but for now, we're just going to do this, grouping them 2 at a time. So here's the problem. When I group this second set of parentheses, if I wanted to get rid of, if I want to work backwards from what I just did, if I wanted to get rid of the parentheses, if I distribute positive 1 over these, I still have AD plus 3A, and that is what I started with up here. But if I distribute this negative 1 over these 2 things, it means that I have minus d squared, but I have plus 3d. And as we can see, that was not our original expression. In other words, by putting the parentheses where I did, I have changed the value. So instead, if I start out with AD plus 3A minus, and that's the thing you got to pay attention to when that's a subtract. When I put the parentheses around it, if I don't want to change the value, I need to change the second sign over here. It has to, this sign switches. Okay? So these are the ones you're looking for. When the middle sign, if the middle sign is subtract, you have to change the last sign to its opposite. Okay? And what I'm going to do now is I'm going to do that problem. So, we're going to do it from start to finish. We've got AD plus 3A minus D squared minus 3D. So, ding, 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 I have to see this sign is a negative. So when I put in my parentheses, I have to make this the opposite of what it is, because this sign tells me I'm taking the opposite of everything in the parentheses. Now, if I did get rid of the parentheses, you would see that as the original expression. But let's finish. After I group, I want to pull out the GCF. A times D plus 3 minus D times D plus 3. And then in one parentheses, I put A minus D. In the other parentheses, I did D plus 3. Let's look at another one. A squared plus AB minus 3B, no, sorry, minus 3A minus 3B. Okay, again, ding, 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 that's a minus sign. So when I group, I have to change that to its opposite. If it were plus to begin with, I'd change it to minus. I pull out the greatest common factor, and the greatest common factor is here is 3, and then I finish. A minus 3 times A plus B. So if I want to look at any of these, I can just see if I've got, oh no, I'm not going to do that one. Okay, so basically, don't forget, if there aren't any parentheses, you want to group, take the GCF of each group, factor out GCF of each group. But I would say watch out for middle subtraction sign. Factor out the GCF of each group. And then finish.